We are going to learn about finding the determinant of a 2 by 2 matrix. And there's a formula you need to know. So let's say we have matrix A, which is equal to the entries little a, b, c, and d. The formula for finding the determinant of A, which is usually written like this, is AD minus BC. So this is the formula. And I want to clarify that this formula only works for a 2 by 2 matrix. It does not work for any matrix sizes other than a 2 by 2 matrix. If the value of AD minus BC is any number other than 0, the matrix is invertible, meaning that we can find the inverse of the matrix. Therefore, if the determinant does not equal 0, the matrix is invertible. However, if the determinant does equal to 0, hence AD minus BC equals 0, then the matrix is not invertible, meaning that we cannot find the inverse of the matrix. So let's do some practice problems. Let's say we have matrix B that is equal to 4, 6, 2, 1. What is the determinant of matrix B? First, let's check if this is a 2 by 2 matrix, as the formula for the determinant will work only if the matrix is a 2 by 2 matrix. Matrix B has 2 rows and 2 columns, so matrix B is a 2 by 2 matrix. So let's label what A, B, C, and D are. A equals 4, B equals 6, C equals 2, and D equals 1. So let's use the formula AD minus BC to find the determinant. The determinant of B equals 4 times 1 minus 6 times 2. We are just substituting A, B, C, and D in the formula mentioned in the beginning of the video. 4 times 1 is 4, and 6 times 2 is 12. So we have 4 minus 12, which equals negative 8. Therefore, the determinant of matrix B equals negative 8. Since the determinant equals negative 8, which does not equal 0, the matrix is invertible. Let's try another example. Let's say we have matrix L that is equal to 8, negative 4, 2, negative 1. What is the determinant of matrix L? First, let's check if this is a 2 by 2 matrix. Matrix L has 2 rows and 2 columns, so matrix L is a 2 by 2 matrix. So let's label what A, B, C, and D are. A equals 8, B equals negative 4, C equals 2, and D equals negative 1. Let's use the formula AD minus BC to find the determinant. The determinant of L equals 8 times negative 1 minus negative 4 times 2. We are just substituting A, B, C, and D in the formula. 8 times negative 1 is negative 8, and negative 4 times 2 is negative 8. Negative 8 minus negative 8 is negative 8 plus 8, which equals 0. Therefore, the determinant of matrix L equals 0. Since the determinant equals 0, the matrix is not invertible. Let's try another example. Let's say we have matrix S that is equal to negative 8, 4, 9, 2, 0, 1. What is the determinant of matrix S? First, let's check if this is a 2 by 2 matrix. Matrix S has 2 rows and 3 columns, so this is not a 2 by 2 matrix. This is a 2 by 3 matrix. Since this is not a 2 by 2 matrix, we cannot use the formula we learned in this video to find the determinant. In fact, this is not a square matrix, so the determinant does not exist. there is no way the determinant can be calculated. A square matrix is when the number of rows and columns equal each other. Examples of square matrices are 1 by 1 matrix, 2 by 2 matrix, 3 by 3 matrix, 4 by 4 matrix, etc. All of these matrices have the same number of rows and columns. Since matrix S is a 2 by 3 matrix, where 2 is the number of rows and 3 is the number of columns, and 2 does not equal 3, this matrix is not a square matrix, so the determinant does not exist. Let's try another example. Let's say we have matrix W that is equal to 5, 6, 2, 8, 4, -1, 3, 4, 6. What is the determinant of matrix W? First, let's check if this is a 2 by 2 matrix. Matrix W has 3 rows and 3 columns. So this is not a 2 by 2 matrix. This is a 3 by 3 matrix. Since this is not a 2 by 2 matrix, we cannot use the formula we learned in this video to find the determinant. However, this is a square matrix, since the number of rows equals the number of columns. Matrix W has 3 rows and 3 columns, hence it is a 3 by 3 matrix. Therefore, the determinant of matrix W exists, but we have not yet learned how to find the determinant of this matrix, as this video is only for finding the determinants of 2 by 2 matrices. I put this example in this video to stress that the formula AD minus BC is only for 2 by 2 matrices. For finding the determinants of 3 by 3 matrices, 4 by 4 matrices, 5 by 5 matrices, etc., we need to use other techniques. So the answer for this question is that the determinant for this matrix exists since it is a square matrix. It is a 3 by 3 matrix. But we do not know how to solve for the determinant yet.